So in this question, we have a familiar situation where we have a ball moving to the right at 5 meters per second. It hits a wall and it rebounds at a speed of 3 meters per second. In terms of defining our directions, right is positive, left is negative. So that means we have a plus 5 meters per second and a minus 3 meters per second in terms of the velocities. So we could start out two different ways. We could start out with just our definition of the net force, which is m delta v over delta t. Or we could start out with our four-way equivalence, J equals delta P equals F delta T equals M delta V. So, of course, we see a lot of similarities in the red method or the blue method. We're looking for the force, and we've got times and masses and velocities. So bringing those two down and solving for F, we're left with M delta V over delta T, the definition of the net force. So ultimately, it doesn't matter which way we start. We're going to end up with the same result. So we have a mass of 0.40 kilograms, our change in velocity, which is v minus v0. The final velocity is minus 3, minus the initial velocity of 5, all over the time, which is 0.20. So that's a 0.40 over 0.20 times a minus 8. So see, these will cancel. They'll reduce, I should say, and we'll end up with 2 times minus 8, which is minus 16 newtons. Now, the question's asking for the magnitude, meaning the direction doesn't matter. So that gives us 16. But if we were to examine this a little more closely, what we could see is the force that's operating in this direction is the force of the wall on the ball. And the force that's operating in this direction is the force of the ball on the wall. And they're looking for the ball on the wall, which does have a positive direction, a positive force. So that's why, for a number of lines of reasoning, that the force of the ball acting on the wall is 16 newtons.